review the sine and cosine laws from grade 10. Looking at a non-right angle triangle, we can't use SOHCAHTOA, so we needed to have other methods to solve in a non-right angle triangle. So sine law is the first one we're going to take a look at. And if we see that we have created our altitude, remember from last year as well, altitude through a vertice perpendicular to the opposite side creates the height of our triangle. Using that, we can take a look at in our left triangle here, the sine of angle B, so talking about our right angle triangle on the left-hand side, sine of B is equal to H over C. If we want to solve for H, we would take C over to the other side and calculate C times sine of B is equal to our height. In our triangle on the right, again, sine of angle C would be equal to our height over side B. To isolate our height, we take the B to the other side, so height is equal to B times sine of C. Well, if each of these is equal to height, then we know that C sine B has to be equal to B sine C. And if we just write or take our sine of our angles over to the other sides, we notice that C over sine C has to be equal to B over sine B. And this is the sine law. So to find a side, putting our sides on the top, A over sine A is equal to B over sine B is equal to C over sine C. And again, notice lowercase letters for sides, uppercase letters for angles. Well, if we're going to find an angle, it's easier to have our missing piece of information already on top. So we can just rewrite all of these ratios and flip them all. And we can do this because the ratios are equal no matter which way they're written, as long as all the sides are on top or bottom and all the angles are on the other one. So to use the sine law, we have to be able to fill in both a side and an angle. So we have to be able to have two pieces to fill in a full ratio to solve for the missing piece. Cosine law. So again, coming up with our cosine law from our non-right angle triangle using our height again, we notice that in the left triangle, we know that height squared plus this little piece in here, which we're going to call x, so height squared plus x squared is equal to c squared. Okay, to solve for c, we have a right angle triangle in here, and we can use Pythagorean theorem to solve for that. Well, if we are going to solve for angle B, we can also set up in general that the cos of B is equal to x over c. Okay, so if we also wanted to solve for x, we could take c times cos of b over to isolate x. Okay, so we're going to keep those in mind, keep that straight from a moment. Now, in our triangle over here, we can again use Pythagorean theorem that to solve for b squared, we can take height squared. And what we're going to do with this little part over here is we're going to call this a minus x. So if a is all the way across here and we've made this x here, then this has to be a minus x. So we're going to have a minus x squared, and simplifying or foiling to actually multiply a minus x times a minus x, we know we get a squared minus 2ax plus x squared. Well, we notice that this x squared and h squared comes from up here. So what we can do is replace the h, so just rearranging this, we can now replace that with c squared. And we also notice that here we can replace with c cos b. So we're going to have 2ac cos b. And this is exactly what cosine law means, or how to find a side using cosine law. Okay, so we should be able to derive those formulas looking at our oblique triangles. So to find an angle, we rearrange the equation. So if we had b squared equals c squared plus a squared minus 2ac cos b, and we want to isolate cos b, well, we're going to bring everything over to the other side that was with this chunk of information because we want to make this a positive. At the same time, we're going to bring our b squared over, and just notice I just wrote these in reverse. And now if we want cos b all by itself, we're just going to take our a squared plus c squared minus b squared, and we're going to divide it all by 2ac. Again, this is how we would calculate an angle using cosine law. Now, it doesn't really matter what the labels of our triangle are, as long as we know that whatever we're solving for, we have that side squared, the other two sides squared and added, minus 2 times those sides times the cos of the angle. And this comes from a case where we have side angle side, and we know this side, and we know this angle. So it has to be, to solve for the other side, we only have these 3 pieces of information. So to find a side, a squared, we would have to take the other 2 sides squared and added together, subtracting 2 times those sides times the cos of the angle with the side we're working with or need to find. Same thing, c squared would be equal to a squared plus b squared minus 2ab cos c. To find an angle, we could rearrange any of these formulas, but easiest, cos of a, other 2 sides squared and added, subtracting the square of the side that is with that angle over 2bc. So find the indicated side or angle in the following examples. The first one, we have a case of side, side, side. All we have are sides, which means we can't use sine law, so we have to use cosine law. And we have to use the angle form of the formula because we don't have any angles. We know all the sides, we need to find the angle. So we're going to use cosine of b. So we start with the other 2 sides squared and added together, subtracting the square of side b over 2ac. Subbing in, we have 14 squared plus 7 squared minus 8 squared. all divided by 2 times 14 times 7. And remember, this is going to give us the cosine ratio. This is going to be a decimal. So we're going to have to do our inverse cosine to find the angle that that ratio goes with. And we can do that all in one step in our calculators. And we would just put into our calculators 14 squared plus 7 squared minus 8 squared divided by, and make sure that we put the bottom in brackets. 2 times 14 times 7, end bracket, equals, gives us our decimal. And now we're going to press inverse sine to get our angle. Rounding to the nearest degree, because our question doesn't tell us any different, we see that angle B is equal to 23 degrees. Part B, now we need to solve for side U. Taking a look, we do have, so we want to use sine law if at all possible, and we notice that we do have a side and an angle that go together, so we want to take a look at sine law. Now, we want to solve side U, so we want to be able to compare that ratio to our U ratio. Well, we don't have angle U, but we notice that we do have angle T here, which means that angle U is going to be equal to 180 minus 44 minus 114, which means that angle U is equal to 22 degrees. Now we do have our angle here that we can use to find side U. So since we're going to find side U, we're going to set this up. U over sine U equals S over sine S. And subbing in what we know, angle U is 22 degrees, side S is 33, and angle S is 114. Taking our sine 22 over to the other side where it becomes multiplied, and putting that into our calculators, 33 times sine 22 divided by sine 114 and equals, and rounding to one decimal place, we see that U is equal to 13.5 meters. Part C. Again, we need to find a side, so we do have the angle that goes with it for a full, or for angle P to go with our ratios, but we notice that we don't have angle R and we don't have angle Q, which means we can't use sine law. And this is an example of side, angle, side, that we have an angle in between our two sides that we're given, which means we don't have a full ratio to use sine law. We have to use cosine law. So we're going to set this up. We need to solve for side P, which means we're going to have our Q squared plus R squared minus 2QR times cos of angle P. Subbing in, we know that Q is 10, R is 12, and we're going to have 2 times 10 times 12 times cos of 123. And we can do this all in one step. This is the only thing we need to find, so we can round this to one decimal place. So we can put all of this in, 10 squared plus 12 squared minus. Just remember that we want to put brackets around this entire chunk so we have an answer to that. Multiplication has to be done before subtraction. So 10 squared plus 12 squared minus bracket 2 times 10 times 12 times cos 123 equals. And remember, we still have to square root that. So square rooting the answer, we get 19.4 centimeters. And example number 2, here we want to find x. Notice we have two different triangles here. We want to use what we know here. So in our right angle triangle, in order to find x, remember all of our SOHCAHTOA consists of two sides and an angle. Well, we have an angle. In order to find a side, we would need a second side. Well, we don't have that in triangle ABC. So now we're going to look at our other triangle, triangle BCD, to see if there's anything that we can find. We notice that we have a common side. So we're going to first of all start with, and remember we want to be very specific about which triangles we're working with. In triangle BCD, we want to find side D. Well, taking a look at, we do have the angle, but notice we have side, angle, side in our non-right angle triangle or our oblique triangle. So we want to find side D using cosine law. Side, angle, side tells us automatically cosine law. So we're going to find D squared by taking B squared plus C squared minus 2BC cos of angle D. And when we do that, we're going to sub in 82.7 squared plus 64.8 squared minus 2 times 82.7 times 64.8 times cos of 54. And again, we can put that all into our calculators, remembering the last portion goes in brackets, square rooting the answer that we get. Now notice we're not going to round this answer quite yet. We need to use this answer in the next step, so we want to be as precise as possible. So we're going to keep this number in our calculator and hope that we can use the entire thing. If not, we need to write down at least 4 or 5 decimals to make sure that we have as precise as we can. So now that we know side A in triangle ABC, we're going to use our cosine ratio because we know from angle 48 we have our adjacent and hypotenuse. So we know that cosine of 48 degrees is going to be equal to our 68.8367 divided by x. We're going to take x to the other side where it becomes multiplying, and we're going to divide by cos 48. Now notice that we already have this number still in our calculator from the previous step, so we're going to use that exactly like that and divide by cos 48. When we do that, we get, and we notice this is our final answer, so we can now round this to our 1 decimal place for a side. So x is equal to 102.9 meters. Okay, so that's a quick review